And welcome to Lehigh Nation. We're going to start with some differentiation today, and it's going to be a general differentiation. And we're going to do f at x equals to negative 3 sine x. This is a mixture of different functions, and so I'm going to be going through it with you as I do it. Now, we've got the derivative of, we got to find the derivative of negative 3 sine x. Very easy. All you have to do is figure out what the derivative of sine x is and then tack on a negative 3. Right? So the derivative of sine x is cos x. So it's going to be negative 3 cos x. And we're done. Part B is f of x equal to 5 cos x. Now we've got to find its derivative. So its derivative of, or rather the derivative of cos x is negative sine x. Then you tack on the 5, it's going to be negative 5 sine x. Okay, so the derivative of sine x is cos x, but the derivative of cos x is negative sine x. Remember that. Next, we've got f at x equal to negative 4 e to the x. The derivative of e to the x is itself. It's e to the x. So really, it's just itself. Okay, so it's negative 4 e to the x. Next. F of x equal to negative 2 ln of x. The derivative of ln x is 1 over x. So the derivative of negative 2 ln x should just be negative 2 over x. Oops, there is no part E. We're going to do number 5. Okay, so now it's going to be a sum of terms, and we're going to do it all at once. Now the derivative of let's do, I don't have to rewrite it. Let's just do f prime of x. Okay, so the derivative of 1 is 0. Okay, the derivative of 2x, okay, is 2. So I'm going to put a minus because we have a minus here. And the derivative of x squared is 2x multiplied by 3. That's going to be 6x. Okay, so in the end we get negative 2 plus 6x. Done. Part B is a little harder because we got 2 over x. So f prime of x, let's see, the derivative of x is 1. Okay, 2 over x can be written as 2x to the negative 1. Okay, so I know its derivative, using the power rule, is going to be minus 2 over x squared. All right, now 3 over x squared can be written as 3x to the negative 2. Okay, keep in mind though that there's a minus in front right there. Right? So what I have to do is I have to accommodate for this minus that's going to come down. It's going to be positive instead, positive 6 over x to the 3. Okay? And finally, it's going to be a derivative of x cubed, and that's 3x squared. And we're done. Part C, f prime of x. Again, the derivative of sine x is cos x. Derivative of cos x is minus sine x, negative sine x. So it's going to be cos x plus sine x. Okay, and the reason why we have a plus is because we already had a minus here, so the minus and minus makes a positive. I'm going to do part D over here. Part D, the derivative is very simple, straightforward. It's minus 2 e to the x plus 3 over x. Done. Okay. Next, finding the equation of the tangent to a given curve at a point. Okay, so I need the derivative first, right? So whenever you're in calculus, when in doubt, just take the derivative. Okay, so it's going to be 3x squared minus 6x. All right. Now they want the derivative. They want the equation of the tangent line, right, which involves a slope and a y-intercept at a given point, right? And this point has an x value. The x value is equal to 1. Okay, so what I do to find the slope at that point is I sub in x equal to 1 into the derivative function. So 3 times 1 squared minus 6 times 1 equals 3 minus 6 equals negative 3. So that's the slope. Here's what I want you to do next. I want you to use the point that they give you, okay, as an x1, y1, and then make a general point P, x, y, such that this is x2 and y2. And I want you to write down the equation of the slope. We know what the slope is. Slope is y2 minus y1 over x2 minus x1. right? So now just use your equation and the points that both that you made and that was given to you. So it's going to be y minus y1, that's negative 2, so minus negative 2, that's a plus 2, over x minus 1 equals to our slope, which we found to be negative 3. Now, what I want you to do is I want you to multiply both sides by x minus 1, okay? So we're going to get y plus 2 equals to negative 3 x minus 1. Next, expand, and we're going to get negative 3x plus 3. And so now what we have to do is we're going to put it in standard form. ax plus by plus c equals 0, okay? Where a is positive, all right? So I'm going to move 3x to the other side. So I'm going to add 3x to both sides, right? So it's going to be 3x plus y, and I'm going to subtract 3 from both sides, and so I'm going to get plus 2 minus 3 equals 0. 2 minus 3 is negative 1, so I'm just going to put minus 1, and I get my answer. And so that's how you find the equation of a tangent line given a function and a point. Okay. Now next, what they do is they actually give you the slope, right? So they actually give you the slope. In number 7, it says find the equation of the tangent line that has the slope negative 6 to the curve so and so. Okay. Now things are a little different. We're not given a point, right? So it might be a little more difficult to construct our slope equation y2 minus y1 over x2 minus x1. So we need to figure out what to do. Well, what we can do is we can still, again, when in doubt, find the derivative, right, of the function that they give you. Well, the function is x to the 4 minus 2x. So its derivative is going to be 4x cubed minus 2. All right. Now, we know that the slope is negative 6. All we have to do is find the x value that gives us that slope of negative 6. So we equate both sides. We equate the derivative to negative 6 and solve for the x value. From that x value, we can plug that x value back into our y to get our y value, and we'll get our point, and then we can just go ahead with making our equation. So here's what we're going to do. I'm going to divide both sides by 2. First of all, that makes things easier. So it's going to be 2x cubed minus 1 equals to negative 3. 2x cubed will equal to negative 2. X cubed will equal to negative 1. And x must be negative 1. I'm going to recheck it. Divide both sides by 2. 2x cubed minus 1 equals negative 3. 2x cubed equals negative 2, x cubed equals negative 1, and x equals negative 1. Perfect. Now, if I plug that back into my original equation for y, I can find my y value, and it's going to be the quartic of negative 1. I hope I said that right. A quartic of negative 1 is a square of a square, and that's going to be 1 minus 2 times negative 1. That's going to be 3. Okay, so my point of interest is, I'm just going to call it P, negative 1 comma 3. Okay, and so now I've got x2, I usually call this x1, y1, and I'm going to generate another point P prime, and don't get confused, this isn't, you know what, I'm not going to call it P prime, P bar, x, y. Okay, and this is going to be x2, y2. Sounds good. And so my slope equation will be negative 6 equals to y2 minus y1 over x2 minus x1. Okay, and so if I work this out, I get negative 6x minus 6 equals y minus 3. And again, I want my value in front of x to be positive, okay, in standard form, and so I get 6x, I add 6x to both sides, I get 6x plus y plus 3 equals 0, and that is my equation. Okay, work it out. If you manipulate this, you should get this guy. All right, next, at what points on the hyperbola xy equal to 12 is the tangent line parallel to that equation? Now what they're looking for when they say parallel is at what points xy that are a part of the equation xy equal to 12 at what points do the tangents have a slope of have a slope that's parallel to this line. Now, when you have two parallel lines, right, they have to be the same slope, right? So this guy is a line, okay? It'll have the equation y equals negative 3x. So the slope here is negative 3. That means if I take a derivative of my hyperbola equation, right, I equate it to negative 3, and I can find the x and y values that satisfy that equation. What that involves is either doing, you can either do implicit differentiation if you like, or you could just isolate for y and then take a standard derivative that you normally do. I'll just do implicit differentiation because I haven't done it yet, and it might be really good to get that going. This is a product rule, okay? I'm going to take the derivative of both sides, all right? So the derivative of xy, okay, equals, it's going to be a product rule, so let's call this u and let's call this v. Okay, so the product rule is u prime v plus v prime u. So the derivative of x is equal to 1. The derivative of y equals y prime. So here's how you work it out. You go, it'll be 1y, okay, plus x y prime, and that's on the left side. The derivative of 12 equals 0. So you end up getting y plus x y prime equals 0, and so y prime equals to negative x over y. Oops, I think I did it wrong. It would be negative y over x. Sorry about that. Negative y over x. Okay. And so I get that as my derivative. Now the derivative has to be negative 3 again because they're parallel, right? So I set it equal. So I go negative y equals to negative y over x equals negative 3. The negatives will cancel, so y should be equal to 3x. Okay, now I've solved for y in terms of x, and we know that no matter what, the points of interest have to lie on this hyperbola, meaning they have to satisfy that equation. So all I have to do is plug in this y value, which is 3x, into my equation and solve for x to get the x values of the points. So I do that, and I get 3x, okay, times x, right, that's part of the equation, x is still there, equals to 12, which means that 3x squared equals to 12. So x squared equals 4, and so there's only 2 points of interest. It's going to be x equals plus or minus 2. But if x equals plus or minus 2, y is 3 times that, right? So y should be plus or minus 6. So there's only 2 points. It's going to be 2 and 6, or negative 2 and negative 6. And that's it, these 2 points. Okay? You can call them P1, P2 if you want. It doesn't matter. All right? So that's equations of the tangent. Now I'm going to do more differentiation, and this might involve, a chain rule or just straight up product rule, but we shall see. I don't think number 9 needs any chain rule, to be honest with you. It's easy enough. But it will be, looks like you'll need product rule for sure. Okay, so product rule, 9a. We've got f of x equals to x minus 1 times x plus 2, right? So the derivative, again, is a product rule, so it's going to be u, v. All right, and I like to split things up a bit. I think it's easier to do it that way. So u prime, right, equals 1. V prime also equals 1. Okay, so it's very straightforward. Remember, the product rule is u prime v plus v prime u, right? So f prime of x should just be 1 dot x plus 2 plus 1 dot x minus 1. And it's that simple. Okay, so you end up getting x plus 2 plus x minus 1, and you end up getting 2x minus or plus 1. And that's that. Now let's do part B. Part B has some square roots. Okay. Now, what I'm going to do, I think, is instead of no, actually it's not too bad. I'm just going to go with it. So call this u, call this v. Okay, so u prime, okay, I said in previous videos that the root of x, the derivative of it, is going to be 1 over 2 root x. So it's going to be like that, right? Same goes for v as well, actually, because the minus 1 doesn't really do much. So 1 over 2 root x. Okay, so if I use this product rule, right, which is the product of a, or the derivative of a product, I end up getting that f prime of x equals 1 over 2 root x times root x minus 1, okay, plus 1 over 2 root x times root x. Now the root x's here will cancel, all right, and they will partially cancel over here as well. So we get 1 over 2 minus, and this is after I do an expansion, right? Minus 1 over 2 root x plus 1 over 2. The 1/2s make a 1 together, and you get 1 minus 1 over 2 root x. Sorry if it's a little hard to read. So you end up getting 1 minus 1 over 2 root x. Another way to do this, right, that may have made my life, could have made my life easier, is if I expanded root x inside, I would get x minus root x, right? And then I can take a derivative from there, and that would give me exactly this, right? So that might have made things easier, but it always helps to go through these examples. You start to get the rhythm of things. You can get the answers much faster over time. Next, you've got the derivative of x sine x. Well, the derivative of x is, I'm going to call that u, so u prime would be 1, v prime would be cos x, right? So it's just going to be 1 times sine x plus x times cos x. So it's just going to be sine x plus x cos x. Done. Okay, and now if I call u x, right, and v e to the x, then I know that the derivative of e to the x is itself. So v prime is actually e to the x. U prime is just going to be 1, right? That's the derivative of x. So, and that's, so part C, the f prime of x would just be, it would just be 1 dot e to the x plus x e to the x, and so I can take a common factor of e to the x out, and I get e to the x times x plus 1. Okay, so that's part C. Oh, that's part D, actually. That's part D. This is part C right here. Okay, so with that being said, we can go on with part E. And so part E involves e to the x ln x. Again, the derivative of ln x is 1 over x, and the derivative of e to the x is itself, right? So this is actually pretty straightforward. Let's see, let me erase this. So if we call u e to the x, then u prime equals e to the x. If we call v ln x, then v prime is 1 over x. Okay, so let me do it all over here. I wish there was a way to increase the thickness of the eraser very quickly so that I can move on from problem to problem. So e to the x ln x. All right, so the derivative would then be, it would be e to the x ln x, right? Nothing's changed, right? Because I'm doing u prime v, plus v prime u. It would be 1 over x e to the x. So again, there's a common factor of e to the x. So I just factor out e to the x, and I get ln x plus 1 over x, and I'm done. Okay. Now, in question 10, chain rule helps so much. It's ridiculous. Chain rule will help you a bunch. don't, I mean, you can do these derivatives normally, like without, doing like a change of variables and calling something a different letter. But I love doing chain rule because if you do a bunch of questions without chain rule explicitly, then you will like freak out, right? And you'll, after like 30 questions, you'll have a headache. So let's do 10a. 10a. F of x equals 2x minus 1 squared. Okay, so I'm going to let this whole thing equal to z, or z if you're American. And so this guy becomes a function of z, and it becomes z squared, right? So chain rule says that df dx, right, is just going to be df dz dz dx. Okay, now this is why I did it this way. Df dz is very easy. It's like taking a derivative of x squared, right? So df dz is just going to be 2z. dz dx is even easier. dz dx is just 2, right? So all it's saying to do is to put them together. So I get 2z times 2, and I get 4z. But what did I call z? I called z 2x minus 1, right? So the derivative will just be 4 times 2x minus 1. And so I finish it by expanding, and I get 8x minus 4, and I'm done. Part B, let's see, we get f of x equals to x minus root x squared. Okay, and I'm going to call this guy z again, right? Z equals x minus root x. And so I'm going to do the derivative. Let's do it. So df dx, right? And this is Leibniz notation. Do not get scared. It's just f prime of x. Okay, equals df dz times dz dx. Okay, again, this is like z squared, right? So this part is 2z. And then this guy's derivative is going to be 1 minus 1 over 2 root x. But again, z is this guy, so you get x minus root x. Don't forget the 2. Times 1 minus 1 over 2 root x. So if you want, you can do an expansion. I typically just leave it, right? Like in this factored form, it's much easier to just deal with. Especially when you're like having to plug in certain values, it's just honestly easy to leave it in factored form. You shouldn't really get mistakes, or not mistakes, marks off if you leave it in factored form. I think that would actually be okay. Let's see. I'm just going to finish at number 10, and then I'm going to leave the rest for another video. So we've got C, okay, f of x equals x squared plus x plus 1 to the 100. Again, call this z, okay. So the derivative, df dx, is just going to be the derivative of z to the 100 times the derivative of x squared plus x plus 1. Okay, so the derivative of z to the 100 is just going to be 100 z to the 99. That's power rule. Times 2x plus 1. And so I just finish it off by punching in what z was. Z was x squared plus x plus 1. 2x plus 1, and I'm done. That's it. And then we've got d, which is f of x equals sine cubed x. Now, don't be confused. When it says cubed, this can be rewritten as this. And I've seen a lot of students rewrite this like this. Bad. These are totally different. These are not the same. Okay? So it's the cubed of sine x, essentially, right, that we're working with. So again, now call z sine x, right? So df dx is going to be the derivative of sine x, or yeah, the derivative of sine x, which is cos x. Nope, I'm making a mistake. It's going to be the derivative of z squared, or z cubed, right? I don't know why I'm off right now. Z cubed, which is 3z squared, times the derivative of sine x, which is cos x. Okay, now z is sine x, so I just punch that back in, and I get sine squared x dotted with cos x. That's multiplication. One last problem for the video. We've got f of x equals ln x all to the power of 5. Okay. Ln x all to the power of 5, this can be rewritten as z to the 5, okay, so long as z is ln of x, and so df dx is going to be 5z to the 4 times the derivative of ln x, which is 1 over x. Now, z is ln x, so it's going to be 5 ln x all to the 4 over x, and we're done. Okay, thank you so much for watching and for supporting us. It really means a lot. I'm going to finish the differentiation next time, especially the acceleration and velocity, and then so that's going to be the next video. After that, I'm going to do derivative signs, intervals of increase and decrease, and critical values, and then concavity in a separate video. And then I'm pretty much, aside from like curve sketching and optimization, I'm pretty much done with calculus, and then I'm going to start what I've always wanted to do over YouTube. I'm going to start vectors because I'm a physics guy. Thank you so much for supporting us, and if you can, like, comment, subscribe, and share. You guys really make my day when you send in your questions, and I love doing this stuff, and I don't think that'll change anytime soon. And I do this all for fun, so if you could support us in that cause. We're also on Patreon now, so look for us on Patreon. I think I'm going to leave a link to it in the description below, so if you can support us, that'd be really great. But other than that, have a great day, and hope that this video helps you, Lehigh Nation. Have a good one.